My name is Rajesh Gupta. So I work for Thales. Thales is into data security. Oh, sorry, guys. Yeah. So at Thales, basically, we protect data from at all the level, from application to storage, whether at the file system level. So thanks, Eric, for setting up the stage. And I'm just going to go a little bit more detail into the ransomware attacks and how it can be prevented and what can be done to protect your data. So Peter, sorry, just to start the session, Peter was supposed to be here because of some prior commitment. He's not here. So if there are a lot of technical questions, I'll defer to, I'll ask you guys to reach out to me later. So Thales did this survey with the financial industry. So 19% of the industry, they said basically they have been attacked by ransomware. They have been the target. 52% have the formal plan, and 17% said basically they would pay the ransom. So basically the ransomware is changing the economy. So how these attacks, how the data is being attacked today? So just a few days back, LockBit is basically the most prominent malware, which is basically trying to, and they have changed the whole game. From LockBit perspective, why do we want to encrypt the data? They are changing the game. They are saying basically locking the data does not provide us anything. They are just basically threatening companies to basically they will disclose the data. So company still has the data, they have control of the data, they will disclose it. Why encrypt the data? Why do anything? So in the ransomware world, pretty much every day, it's evolving, it's changing how the data is being attacked. So there is some stats on this page. So according to FBI, more than 2,000 companies, basically, they reported ransomware attacks in 2021, and it's going up. And majority of the ransomware attacks were basically through emails. So malware spreading, and that's because of the COVID-19. There are a lot of misinformation was flowing. And this is a very interesting stat that average downtime for a company was 22 days, and that's a big loss for any organization. Especially you can see about the banking and finance industry, and 22 days is a big, huge loss. So what we are trying to do here is basically how there are a lot of solutions today. What I'm trying to dig deep into is basically how these solutions are falling short of protecting the data, and what is the global market value of those solutions, and how these attack vectors are introduced to the system. So these are some of the details I'll go into. So when it comes to protecting the data, the traditional access control is not enough nowadays. So in most recent attacks, malware is going after your credentials. Once they have the credentials, all bets are off. It does not matter what kind of access control you have on your data. All those basically access control they are easily bypassed. Signature-based verifications are falling short. I mean, 0 days attacks are becoming more sophisticated, and administrators don't even know basically that their network is under attack or their data is under attack, because these malwares are basically sleeping for months and months, and all of a sudden they wake up one day and start exfiltrating your data. So what we are not trying to do is basically we are not trying to do a signature-based recognition. It's a very, very, very complicated solution where you are basically matching the signature after the attack has already happened. And you have to constantly push new set of signature, matching happens and all that stuff. And it does not provide 100% data integrity. I mean, if you don't have the signature of the malware, of the process, what it's doing, you cannot prevent it. Full system security, it's basically, again, in the ransomware world, basically whether you want to protect the system or you want to protect the data. here, basically, in part of the data, basically, I mean, most important thing is your data. If your system is attacked, you can rebuild the system. But if your data is exfiltrated, that's the main point here. So instead of going for the full system, we are trying to basically, the data is the critical part, and that's what we are trying to protect here. So with these solutions, how do we avoid zero-day attacks? Here, basically, as a signature-based attack is basically the post-attack thing, basically where signatures are pushed and then you are trying to match the signature. Here, what we are trying to do is basically we are trying to enable the learn mode, where you learn basically the behavior of the application, you collect the heuristic of the application, what they are trying to do, your data, and then, depending upon that data, trigger the protection. It provides almost 100% integrity. You are building a live signature, live database, where you are understanding the behavior of the processes, and depending upon basically if they misbehave, you can basically protect the data, or you can basically trigger access to the data, or various way you can protect the data. So one of the, multi-factor authentication is one of the way. So as initially basically I mentioned that all these malwares are going after your credentials. So once the credentials are stolen or they are compromised, then all bets are off. So multi-factor authentication, it has been used in various industries. It has been used in banking. It's being used by government sector and everybody. So that's one way to avoid those stolen credentials or credential compromise. So why not implement or why not integrate these multi-factor authentication at the storage level or at the data level? So leveraging the MFA is basically the core solution is when a process or something, the activity on the system is out of character. So you monitor your system, you collect your data, you collect heuristics, and once you see that, hey, this process is accessing my data, and this process is basically trying to delete my data, trying to do something with my data, and just trigger the authentication. So collecting heuristics are basically, it's a recognition phase, recognizing that you are under attack. Data is basically, you have a data set, the type of data, whether it's encrypted, what kind of data application is writing, what kind of data application, what it's trying to do, whether it's trying to delete the metadata, whether it's trying to read, write, and all those user access pattern can be monitored, and you can create a heuristic information out of that. Once you have that heuristic information, then you can understand what is happening on the system, and depending upon that, you can just trigger the MFA on that data. So what is the trigger point here? Trigger point is basically you collected all the information, and on further protected data sets, there are multiple ways you can do that. Either you can deny the access to the data, or you can trigger the multi-factor authentication. So before basically user access the data, you are basically forcing him to authenticate again. And this can be done at the various levels. You can perform at the file system level, you can perform at the directory level, you can perform at the file level. So it all depends basically anywhere where you want, basically depending upon the protection you want, you can put that protection over there. So without this, the validation point here is basically once the out of character nature of the process will be determined, then at that time, basically, you can deny that process access to the data. So you are creating a process set. So you have two kinds of processes. One is basically the user has process which they trust, they have signed, they can access the data without any without any restriction. And then other processes which are running, or any process which could be malware, could be any other process they're trying to do out of character on the system, they can be denied access to the data. So while we were working on this solution and while we were doing the research phase, so what we did, we we understood the behavior of multiple ransomware attacks. So what in that happened is basically they were mostly 90% of attacks were doing the in-place encryption. So they were just reading the data, encrypting the data, and writing back to the same storage. And if you see the similar feedback, similar behavior is backup and restore application, Xcopy-like operation, they do the similar behavior. So no normal user, basically if no user is accessing the data, nobody will try to access the millions of files. They will not try to access the data. They will not try to open, read files. But backup applications are kind of have the same behavior, where you are trying, the backup applications are basically trying to take the full backup. And this is the similar pattern, similar behavior which ransomwares were doing. Just read the data in a short period of time, encrypted it, write it back. So here, basically, just going into a little bit more details of the development, basically how this is happening on the system. So I'm taking an example of Windows development here. So on the Windows, basically, all this activity, all this protection is done at filter manager level. So we have a file system filter driver. At the file system filter driver, basically, we are hooking up to all the callback functions, create, open, metadata operations, clean up, every operation, basically, we are hooking it up here. And once, basically, these callback functions are set, then the learn mode starts. So in the learn mode, we understand the behavior, we collect the information about each and every process. So here, the learning, what is the behavior of the process, what these processes are doing, how these processes are accessing the data, under which user context they are accessing the data, all that heuristic information is created. So in the learn mode infrastructure, this is where we are trying to create the heuristic of the data. So depending upon the user, they can run these heuristic for weeks, for months, and for days. There is no pattern here that you just in one day you can understand the behavior. It all depends upon the data set. This will give you, so information gathered at the data set is then tied to the process. So these processes are kind of basically what these processes are doing, because these malwares are nothing but these are hidden processes which are running on the system. And what the characteristics of that process, that is basically monitored, and then basically the behavior, what they are trying to do, what the activity they are doing, they are associated with those processes. And these processes are given the rating after the heuristics are collected. So once, depending upon that rating, that information is presented to the user, and user can select, okay, these applications which are running on the system, they can be basically put into the whitelist, or they can be trusted processes, or they look at the data and collected data, and they see basically, oh, these processes are not trusted. Either we should block access to these processes, or uninstall these processes, or take action on those processes. So while creating the heuristic, there is no one thing. Basically, there is no one specific thing from malware perspective which you can collect. So under this implementation, we have to collect pretty much every information. So some of the ransomwares, they are very destructive. They just like to delete all the data. Some of them, they exfiltrate the data. They can basically just copy out the data. Some of these attacks, basically, they just do the in-place encryption. And just like Lockbit, one of the recent ransomware, they just control the data. They just say, they are not doing anything on the system. They just control your system. User doesn't even know what is happening. And they just threat that we will expose your data to the outside world. So when we analyzed all these various ransomwares, we decided to basically collect information of various operations. So pretty much every operation on the system, what these processes are doing, and we have to collect the database. So some of the information basically which we collected to create the heuristics are basically open and create. So in a normal world, basically when users are accessing the data, normal users are accessing the data, and you have millions of files, no user will open or create or try to read files in a short period of time. So if that kind of activity is happening, that can basically raise the alarm. It may not stop it, but it can raise the alarm. As backup and other restore application has a similar behavior, they can put it in the whitelist. But this kind of suspicious activity can be triggered or can be basically alarmed to the user. So another operations which these ransomware were doing is they were deleting, they were renaming, and they were changing the file size and all the attributes of the data. So this is the basically there is no one pattern we saw from these ransomware attacks. So what these ransomware attacks are basically, they are every day they are evolving, they are changing what they are doing, and we are just on the tail end basically trying to adjust to their nature. So that's why basically we decided to collect pretty much every information, all the IOs, any activity and application a normal application will do or malware will do, just create a heuristics out of that. And depending upon that heuristic, alert the user or block the data or trigger the MFA so that user can authenticate that the real user is trying to access the data. So what can we do with all this information which we are collecting so far? I talked about all this information. I have all this information. So this information is stored locally. And in some time, basically, in one of our systems, basically, we have an infrastructure user can set up outside the system. It's a lot of information. When you look at the normal production server, you will get millions and millions of IOs per second. So, and those IOs, collecting heuristic on those IOs, analyzing that data, and then continue to basically protect that data will become very slow and it's become very CPU intensive. So all this information which is collected, depending upon basically what information, how we are collecting, it can be analyzed on the local system. So we store it in the registry, and later on these heuristics are retrieved, compared, and MFAs are triggered. But in another way, basically another setup, this information is fed to the external system, which are dedicated for analyzing the data. They analyze it, and they send us the information. This is the analysis from this data, and that analysis is basically retrieved got from the external system, and on that analysis, we just take the decision. It sounds like basically it's going to add performance issues on the system. It's going to add basically delays on the system. So in the real production worlds, how do we handle these scenarios? So in the real production system, basically we are giving option to the user whether to alert or whether to block or whether to basically just trigger for the second factor authentication. It depends upon use case to use case. If it's a very highly sensitive data, users don't care about performance. They just want to protect the data first, even if it's a painful to the user who is trying to access the data. If any user has to go before opening any file or any folder, if they have to go through a multi-factor authentication again and again, it becomes painful. But if the data is very sensitive, so all users are okay. But in certain scenarios, depending upon the sensitivity of the data, it's just the alerts which can be raised, auditing can be done, and the user can take the decision depending upon that. So how this runtime protection is implemented? At this runtime, as we have collected the two sets of databases, one is basically exempt list, one is the protected list. So at the time when the process launch, our driver find out whether the process is exempted or not. And these processes can be signed, so they are fully protected. Malware cannot inject any threads into those processes, so that DLL injection kind of a protection is there. So once we find out basically whether this process is exempted or not, and depending upon the data, depending upon the behavior of the application, the heuristics are matched, and just to ensure that process is doing what it's supposed to do, it's not basically doing any out of behavior activity on the system, we just allow the access to the application. But in certain applications where, depending upon the weight of the application, they can be exempted, like backup applications, they can be exempted by the users. They are trusted, they are signed, so nobody can modify, nobody can inject any threads or any process injection can't happen in those processes. Those processes are exempted on the system, and they can do the normal activity on the system. All these heuristics are available to the users, so they can, depending upon the heuristics, they can determine basically whether these processes are doing the real work, or these processes are basically shouldn't be installed on the system, why they are running on the system. And initially, when we presented this solution to the users, to the customers, they were really surprised to see what processes are running on their system. In fact, basically, in every solution, every POC, we found basically 20 to 30 processes which were running on the system. Administrator didn't even know about that those processes are running. And they have no idea what are those processes. And that was kind of an eye-opener for us, and that's where basically this solution, when we try to present and when we try to show these heuristics to the users, they were really surprised that basically showed the effectiveness of this data collection. So process-specific information, it's a performance, so I already spoke about that. This is a performance burden on this processing. Based on these comparison, the heuristic data, a specific score is applied to the process. So to avoid the performance burden on processing, performance burden on the same system, what we are trying to do, what we did is basically we also applied basically the process score kind of a thing. So there are certain processes which wakes up randomly on the system, perform some operation, go back to sleep. And sometimes they do it once a month or later on. Or basically, just like archiving application can wake up basically at middle of the night, does some activity, then goes back to sleep. And those kind of applications, their behaviors are different. They are kind of randomly basically coming up, going to sleep. So it's pretty hard to detect those behaviors. For those, basically, once we find those processes, once we collect those heuristics, with the help of users, we assign the score to them. Depending upon the score, again, we just allow those processes, we just allow access data to those processes. So how do you protect the data? Once you have the heuristics, once you have all these data collected, so there are multiple ways you can do it. One is you can deny access to the data, but denial access to the data becomes very, very, sometimes applications, if they are basically like a database application, they kind of don't like it, or if the user, it becomes annoying to the users. So depending upon the process score, depending upon the other factors, either the alerts are sent to the users or alerts are sent to the administrator, or depending upon basically the what kind of activity application they're doing and their score, we trigger the multi-factor authentication. So in the multi-factor authentication, users authenticate that I'm the real users, just to make sure basically these are not coming from applications with the stolen credentials and all that stuff. So user is really trying to do it. And when we presented this solution to the industry, so there was a request that for more sensitive data, which is a very confidential data, there will be authentication. Authentication in the sense that if I'm trying to access data, if a user is trying to access the data, he has to get an authorization from a third person, not just do the authentication of his own credential, but he needs an authorization from another person. So that authorization needs to happen. So it's a variety of data, depending upon the data, confidentiality of the data, those runtime protections are applied to the data. These runtime protections, what to do, they can be triggered by the user. User can decide, administrator can configure them, whether they want email notification, whether they want to block the data, whatever they want to do, whatever they want to do with that data. So, and also administrator has the option to basically put those processes into the whitelist as well, in the exempt list. So in the conclusion, in the mitigation of impact of ransomware, it's a very complex problem. As we know, basically the ransomware world is changing pretty much every day. The attack surface is changing every day. How they are attacking, they are evolving pretty much every day. And in fact, majority of the ransomware attacks, administrators don't even know for months and weeks that they are under attack or their data is being infiltrated. So the best thing what we can do is there are a lot of articles where what are the best practices to avoid keeping the backups, making sure you're running all those softwares, endpoint protection softwares and everything. But most of the time they fall short when these ransomware attacks happen. These are evolving, and these are smart people who are trying to basically bypass all these securities which are in place. So the basic principle here is basically from the mitigation of the ransomware attack is basically the zero trust security model. In the zero trust security model, basically don't trust anything. Just authenticate everything at every level. So when you are logging into the network, authenticate. When you are trying to access a critical data, authenticate. So in fact, in this model, basically what we are trying to do is we are trying to authenticate when the user is trying to access the data. Even the authentication is at the file system level, at the folder level. So the normal access control at the file system level or at the storage level is kind of, it does not work. That's a kind of a static authentication. So with this solution, basically the heuristic and all that, heuristic collection and mitigation, we are trying to do the zero-day attack, basically mitigation. So Bottom line is basically we have to implement this zero trust security model where don't trust anything, just authenticate everything before data can be accessed. So this is, thank you for everybody's patience, and yeah, go ahead. Yeah. So the question is basically, what is the deployment model for this solution, whether it's on the desktops or it's a separate. So to answer to that is basically this, we support everything. Basically, you can be deployed on the desktop, you can deploy it on the servers, you can have an external solution where the data is analyzed. So it's like a basically agent which is running on the system, and agent is collecting all the heuristic databases. And then we have implemented at the file system level, driver level, where it just start protecting the data. So depending upon this heuristic collection, how long the data is collected, the decision, and then those decisions are presented, and then you can just check basically what kind of protection is needed. So in this model, we are at the file system level. We are kind of analyzing the patterns, I/O patterns, what applications are doing. So what the data is, we are not doing that. We are not analyzing the data. We are just trying to look at the patterns. So let's say if it's a ransomware which is trying to do the encryption, in-place encryption, so it will try to, let's say you have millions of files, it will try to open the file, read the data, encrypt the data, and write it back. So that pattern looks very suspicious if you have millions of files. So let's say within a 15 minutes of time span, if any process is trying to do this kind of activity, it raises the alert. In the normal world, basically, if you have unstructured data, tons of Excel files, tons of doc files, no user will open millions of files in, let's say, 15 or half an hour time span. So most of the user, basically, its data is structured, right, basically in the folder, and so they access their data. So those kind of activities are monitored. And another activity is like, basically, if, let's say, application just tries to furiously just go ahead and delete the data, start deleting all the files, or start creating files, or start doing various operations, rename operation, or start reading or moving the data. These kinds of alerts, basically, these kind of behaviors are understood by the data collection, the heuristics we collect. So you have a normal application which is running. Let's say you have in-house application which does this activity. So in the heuristic, you will see this application is trying to write to these files. Let's say it's doing millions of I/O per minute. So that is normal activity. So that will go into the basically exempt list. But if there is another application which is not in the exempt list, let's say malware just attacks it, and suddenly it wakes up and start trying to read the data or try to do these activities, that causes a suspicion and then immediately flag and or block the data. So, yeah. Yeah. So, yeah, when we ran this solution in the real world, definitely, a majority of them were false positives. That's where basically, when we worked with our customers, when we did the POCs and all that stuff, that's where basically initial solution which our customer implemented is the alert mode kind of a thing. The alert mode, what they get is they get the auditing, the full audit, and they understand let's say in the auditing we gave the full solution. This user tried to access this data using this process, how many times they did it, what kind of operation they did it, and that's the kind of basically auditing they get. And then depending upon that analysis, then they can put in the policies that, okay, this user is a normal user, this user is a normal user, and any other activity outside these users, these processes, what they are doing, you just block that activity. So usually when you first time install it, yes, there are a lot of false positive. And then you look at the heuristics, and then depending upon the heuristic, you adjust your policies. Once you adjust your policies, any process comes outside of that heuristics will be blocked. So, and again, you can configure it, either block it or trigger multi-factor authentication, depending upon that heuristics, or just alert it, audit it. So. So the question is basically, if the data between two endpoints and the data is already authenticated, user has already authenticated, and they have already encrypted the data, how we are detecting that part. We have one more feature inside this product, which where we do the data analysis as well. But that data analysis is very expensive and very costly, because once you look at the data, start doing the analyzing the data, actual data which is coming in the buffers or which is coming from the application, using the mathematical variations, we can detect whether this data is a clear data or this data is encrypted data. That's one way to detect it, but it's very expensive, and it becomes very slow, because you can imagine basically some of these database applications, they write pretty much 100,000, 200,000 IOs per minute. They go at that rate, and analyzing all that data is not feasible on the live system or production system. Usually, most of these attacks, what our users are talking about, they are basically trying to protect against the process and users, and authenticate them. So once they create the policy, once they understand the heuristic, what is the normal activity on the system, and once that normal activity is clearly understood, then they create the policies, and after they create the policies, rest everything is blocked. So let's say you have a malware which is basically just wake up after 2 months and tries to write encrypted data to the storage. But that process is not part of that policy, and that's how it will be blocked. So I hope that answers your questions. Yeah. Right. Any other question? Yeah. Yeah. So initial heuristic collection, it takes time. It's very slow. So depending upon the workload, what we have seen is performance impact varies from 5% to 20%. So it all depends upon the I/O pattern. A lot of application, depending upon whether application is doing direct IOs, whether they are doing buffered IO, what kind of IOs they are doing, it all depends upon. But the normal range, what we have seen is 5% to 20%, and which is a big impact on IO workload. So there is a fine tuning to that. User has the options to collect what kind of heuristic they want to collect. If they want to just do the process-related heuristics or user-related heuristics, that's where basically we can basically minimize the impact. But yes, yeah, this is basically, that's one of the main reasons basically security is hated, because it adds a lot of processing as well as the performance impact on the production systems. All right, I think, and thank you. Thanks, everybody. Thanks for listening. Right, thank you.